Hey guys, we're going to look at complex numbers. This entire chapter is all about roots of polynomial equations, so we're going to get into all that, but we got to start with just complex numbers. So like I is a complex number. The square root of negative 1 is I. I squared would be negative 1. We'll go through that whole list of all that in a little bit. Should be review of Algebra 2. But we're just talking square roots of negatives. Whenever you do a square root of a negative, it's just going to get an I as the answer. So since that's negative 25, it's going to have an I in it because it's an imaginary number. And then we just do the square root of 25 as normal, which would be 5. Same idea here. Square root of negative means it's going to have an I in the answer. And then we do the rest of it. Square root of 24, normal. But normal square root of 24, you cannot, it's not a integer like the other one was. So we need to actually break it down. So I do this by just dividing by perfect squares. If you can think of a perfect square number that goes into it, like 4, divide it by 4. So 24 divided by 4. Let's actually kind of work this down so I have more room. So let's just take 24 divided by 4. That's going to be 6. 6 cannot be divided by any perfect squares, which means the square root of 6 is going to stay as part of our answer. The square root of 4 is 2, and that's square root of 24 simplified to 2 square root of 6. And then don't forget about the I that we said was going to have to be there because it was a negative. There's lots of different ways to do it. A lot of teachers show it just as doing the factor tree. And then you look for a pair of numbers in there. It's like there's a pair of 2s. Those get to go out. And then your leftovers, 2 and 3, get multiplied back onto the inside. Lots of different methods. You can find another YouTube video on that if you need to brush that up. But hopefully this quick review was enough for simplifying square roots. With complex numbers are when you mix imaginary and real numbers, like 2 plus 5i, that is a complex number. So when we are doing operations like adding, subtracting, it's really just combining like terms, or distributing and basic algebra sort of stuff. Treat it just like a variable. You're going to treat the I just like you would an X. We're going to get it into standard form, which is A plus BI. So we're going to put the real number first and then followed by the imaginary number. So our real numbers, 3 and 2, combine to be 5. Negative 4 and positive 5 combine to be positive 1, I. And we just put it in that order. Real number first, imaginary number second. This requires a little bit of more work. We have to distribute, so that's negative 6 minus 15i. Combine like terms now, so we have 3 and negative 6 is negative 3. And then for our imaginary part, negative and negative is negative 19i. Real number first, followed by the imaginary. When you are multiplying, you would multiply this just like you would binomials in algebra. You multiply the 2 to both terms in the second complex number. Then you distribute that 5i to both terms. So 2 times 3 is 6. 2 times negative 4i is negative 8i. 5i times 3 is 15i, and then 5i times negative 4i is negative 20i squared. Right at the very beginning of this, we talked about I squared is negative 1, so whenever I see I squared, I cross it out, multiply it by a negative, which changes the sign. Cross it out, change the sign. Now combine like terms. So 6 and 20 makes 26. That's our real number part. Negative 8, positive 15 is positive 7, I. That's our imaginary number part. When you have division, don't even really think about it as division, just think of it as a fraction. And we're going to simplify this by multiplying by the conjugate. We've done that many times before. We're going to multiply by the conjugate of the denominator. Conjugate, which means you just change the ending, just like in foreign languages when you conjugate verbs and things like that in Spanish. You conjugate it, you change the ending to match the subject. We're changing the ending here. So we're changing the ending from 4i to negative 4i. Just change the sign of it. So on top, we're going to distribute just like we did on that previous example, 5 times 3, 5 times negative 4, I, negative 2 times 3, and then negative 2 times negative 4. And our denominator, since these are conjugates, remember it has that shortcut pattern. We don't need to multiply everything, we just have to multiply the fronts and the backs. 3 times 3, 4 times 4. So 3 times 3 is 9, 4 times 4 is 16i squared, because positive times negative, so it's negative 16i squared. That's just our shortcut when you're multiplying conjugates, that's what happens, because the rest of it would just cancel out. Now we have I squared. We mentioned that before. I squared is negative 1, so we're just going to cross it out, change the sign, cross it out, change the sign. And now we combine. So for our real number part here, we have 15 and negative 8. Then our imaginary part, we have negative 26i. And then for our denominator, we crossed it out, changed it. 9 plus 16 is 25. So a lot of times you'll see it this way. Sometimes you will actually see them split this up. It's the exact same thing. You're just splitting the fraction to two fractions that have the same denominator because they both have the denominator 25. And then sometimes you'll even see them rewrite the I so it's not on top, but rather just right next to it. So again, we have that real number part and the imaginary number part. We split the fraction just to split those two parts up, so it's real separate from imaginary. But really, technically, either way is just fine. But you will see it written this way sometimes, split up. All right, one more example like this. We're going to multiply by the conjugate again, so 4 minus I. Multiply it to both top and bottom. And we're going to multiply that out, so we get 3 times 4 is 12, 3 times I, 6 times 4, and then 6i times negative I would be negative 6i squared. For the denominator, we can do our shortcut because they're conjugates. Front you get 16, the back you get negative I squared. I squared, we can cross it out, change the sign, cross it out, change the sign, so that's just plus 1. And now we combine our real number parts, 12 plus 6, it's 18. Combine our i's, we get 21. And then 16 plus 1 is 17. And again, sometimes you'll see this split up. Just get used to seeing it. And then, like I said, it might even split that I off to the side a little bit like that. Alright, so the powers of I is just I squared is negative 1, we've talked about that. Now when we put this together, I to the third, that would be an I squared and another I, so that's -1 and another I, which would be -I. I to the fourth would be an I squared and then another I squared if you split it up a little bit, which is -1 times -1, which is +1. This pattern actually goes through the entire, even if you go to like I to the fifth, you can keep breaking it down like this, taking out all your I squareds, but this pattern repeats. It's I, -1, -I, +1, and then it repeats. So this would be I again. And then to the sixth, that would be the same thing as before. That's going to be a -1, same pattern. I to the seventh would be -I, and then I to the eighth would be +1. It's going to keep that same pattern. So one way I like to do this is just make a little, almost like an XY axis of those four things. It goes I1, I1, going around in clockwise order here. I1, I1, like I won, you know, like you're playing a game and you won. So, and then the other thing that makes this nice is it's easy to remember that the bottom two are negative, just like coordinates. The y values would be negative or whatever. So the bottom are negative, the top are positive. And then whatever the exponent is, you just count. You start counting here and going around clockwise. And then 6 and 7 and 8. And you can keep counting all the way around and easily figure out, as long as the number's not too large, you can just count to it, just going around and around and around, and it'll tell you what the answer is. So like we just marked here, I to the 12th, which we just marked, that would be 1. I to the 11th would have been -I. I to the 10th would have been -1, and so on. So you can just keep counting, starting in the top right, going around. Those are the exponents, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so on. Just keep counting your exponents. And then wherever you land, that's your answer. Super easy. Could take a while, obviously, if it said like I to the 96th or something. So there's another trick for that. If you don't like counting, maybe you've seen this one before. If it's an odd power and even power, that tells you right away what it's going to be. If it's going to be I or 1, it just doesn't tell you if it's going to be positive or negative. If it's I to an odd, so if you look at that, the odds were in these two quadrants. These are odds, and both times it was either I or -I. And then the positives are in these two quadrants, and both times you either get 1 or -1. So just by looking at the exponent, you know it's either going to be I or negative, either I or 1, based off of it's an odd or even. Odds are I, evens are 1. Then to figure out if it's positive or negative, you're really just looking to see, is it in the top half or the bottom half? So to figure that out, you just divide the exponent by 2. If it's an even, it's in the top half, and if it's an odd, it's in the bottom half. When you divide by 2, you ignore the, it might end in a 0.5, you just ignore that part. So we'll do these both ways. 30, well, if they're small enough, we can do them the counting way. You could count it out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. And you just have to remember what was in that quadrant. It was I1, I1. So the answer is 1. And that was positive there, so it's +1. Or you follow those two steps without doing all the counting up to 32 or 56 or whatever. We know it's even, so the answer is 1. Just like, well, almost all of these. Even, even. This one's odd, so the answer is I. We just don't know if it's plus or minus. So then we divide by 2, Divide by 2, we get 16. And since that is even, divide by 2. If it's even, it's positive. Odd is negative. So that's even, so it's positive. 106, that is even, so it's 1. Divided by 2 is 53. That's an odd number, so it's negative. Odds are negative. 56 divided by 2 is 28. 28 is even, so it's positive. 101 divided by 2 is 50.5. So that's 50. Remember, we just ignore the 0.5. It's 50, which is an even number. Even tells us positive. So there's another way. It doesn't involve really remembering anything. You just divide. So whatever the entire exponent was, take the entire exponent divided by 4. That remainder tells you what the exponent is. So if the exponent is, or if the remainder right there, the decimal, 0.25, 0.25, probably recognize that means it's got a remainder of 1. It would be 1/4. So you can also go back into this. You can just apply. Let's clear all of this. That those remainders, this would be a 0.25. This would be a decimal. 0.5 decimal, 0.75 decimal would put you here at this answer. And then a 0.0 for the decimal will put you right there. So whatever your decimal is tells you what the answer is too. So when we did 101 divided by 4, we got 0.25. 0.25 means positive I, which is what we said originally. There's lots of different ways to do it. So take your pick, whichever way of those you like. You don't need to know all of them. You just got to know one and make it work for you. All right, so we're going to look at another topic today of division. This should be review also, long division or synthetic division. We're going to do synthetic division whenever we can. But sometimes you cannot. You can only do synthetic division when the thing that you are dividing by is starts with a 1x. Well, we're only going to do it. You can do it if it starts with like a 2x, but I don't like the tricks and things you have to remember with it, so we'll just do long division when that happens. So there's no coefficient with the x. No x coefficient. And then the other part is there can't be anything bigger than an x, like no x squares or anything like that. So no exponents on it either. So no exponents and no coefficients. It has to just be like x minus 2 or x plus 2 or x plus 3 or whatever. That's when we can do synthetic division. Any other time we're going to do long division. So when we do long division, this one we have to do long division because it has a squared. So we'll do a long division example first. When you do long division, you first make sure that you have all the exponents. This one you can see it goes x to the 4th, x to the 3rd. It's missing x squared and x. So we're going to make sure that we have a 0x squared and a 0x when we write this out. 3x to the 4th minus 2x to the 3rd plus 0x squared plus 0x plus 2. And we are dividing by x squared minus 1. If you wanted to put the 0x here, you can. It's not necessary, but some people like to do that. When we do long division, you have 4 steps. First step is to divide. So we're dividing 3x to the 4th divided by x squared. When you divide the numbers. 3 divided by 1 is 3. And then when you divide your x's, you subtract your exponents. So 4 minus 2 is x squared. And that's all we're looking at. We're just looking at the first terms. We divide those first terms. Now we're going to multiply that number back. So that 3x squared, I like to write it down as a distribution problem, and distribute that back right here. So that's 3x to the 4th, and then that would be minus 3x squared. When we do that, we're going to line it up. This is why some people like to put the zeros there, because then you would get a 0 and then minus 3x squared, and everything would line up automatically. Totally fine if you do that. So divide, and then we're going to distribute it back, or multiply it back. Sometimes that's all you got to say. Distribute or multiply. And now we're going to subtract. So subtracting a negative turns that to plus. And now finishing the subtracting here is 0. This would be negative 2x cubed plus 3x squared. I like to continue the rest of it all the way out to the end. That's it. That's our first step. We repeat those same 3 steps. DDS. Divide, distribute, subtract. So now we're dividing again. The negative 2x cubed divided by x squared. So we divide negative 2 by 1, x cubed by x squared. And now we're going to distribute that back. Negative 2x times x squared minus 1. Remember, there'd be a 0 when we multiply that next step, which you can fill in, or just line up after we multiply this out. Negative times negative is positive 2x. And you just line it up with the other x's. Or, like I said, if you put that 0 there, it would work out too. Alright, and then, so that was distribute. Our next step is subtract. So change that, change that, change that. Cancels out. 3 minus 0. 0 minus 2. And then there's just that 2. We're just going to keep it. Back to dividing. 3x squared by x squared. So we start with the numbers. 3 divided by 1 is 3. X squared by x squared. There's no variable anymore. We distribute it. That's 3x squared minus 3. Line it up. And now subtract means change it. Change it. Cancels out. There was nothing here, so when we put those together, it's negative 2x plus 5. This part is your remainder. That's our remainder. When you write your remainder, you write it as a fraction over what you divided by, x squared minus 1. So this entire answer up here is that's your answer, that's your quotient. We're going to do, like I said, we'll do synthetic division anytime that we can. This one we can do synthetic division. You can also do long division. Long division works all the time. That's actually what I've got planned with this one, is we're going to do long division and then we'll do synthetic division again. That's mainly just so we can see long division twice, and you can see that synthetic division works the same way. You get the same answers. So long division, make sure you aren't missing any powers. We're missing a x to the first, so we have 0 x to the first power, and we're dividing by x minus 3. So So divide, distribute, subtract. Those are your 3 steps. Divide x cubed by x is x squared. Now we're going to distribute that back. X squared times x minus 3. And then subtract. Change those signs. And then we start over. Divide 5x squared by x. You get 5x. Distribute. And now subtract, which means change the signs. Cancels out. 15x minus 4. And now we're back at the beginning. Divide again. 15x divided by x is 15. Distribute. Uh, 3 times 15 is 45. And subtract, which means change those signs. 45 minus 4 is 41. So that's our remainder, 41. So we say plus the remainder. Hopefully this stops freaking out on me. Plus the remainder of 41 over the thing we divided by, x minus 3. Your remainder is always just the fraction part at the end. All right, so now we're going to do, it's actually the same problem with synthetic division. The nice thing about synthetic division is it's only coefficients. That's all you work with. And you can do it much, much faster. It only has 2 steps also that you keep repeating rather than divide, distribute, subtract. It only has 2 steps. You add and multiply. Those are your same 2 steps for synthetic division. You just do them over and over and over again throughout the entire process. So, first part is coefficients only. So we take the first, again, like we did in the other one, to make sure you don't have anything missing. We do have a 0x there. X was missing. So we take our coefficients, would be 1, 2, 0, and negative 4. Make sure you take the negative signs with it. And then on the outside over here, you're taking not really just coefficients, you're actually taking this divisor, the thing you're dividing by, and you're solving it. If you said equals 0, you would get x equals 3. 3 is the number that goes on the outside over there. Or quickly, you could just know to change it, because you're moving it to the other side of the equal sign. It's kind of the same process. All right, so now we've got 2 steps. Add and multiply. We add straight down and we multiply kind of in a V diagonally. We'll see that in a second. So add straight down. 1, there's nothing to add, so we get 1. Now we multiply. This is that V I was talking about. You multiply the 3 times the 1, and you put the answer right here in the diagonal. 3 times 1 is 3. And now we repeat that again. Multiply. Add. 2 plus 3 is 5. Multiply. 15. 0 plus 15. Multiply. It's 45. 45 minus 4. When we add those, we get 41. These numbers should be familiar. That 41 is the remainder, and then it was a 1, 5, 15. Those are your coefficients. So as you put this back into a polynomial answer, starting with your remainder over what we divided by, and then 15, that's going to be our constant. To 5 is going to be our linear term. You just got to remember to put your x's back, and they're going to count up. So it's like our this goes our fraction part, our constant, our linear, our x term, and then this would be our squared or our quadratic term. 1 is the coefficient. And if you compare those two answers, they are exactly the same because long division and synthetic does the same thing. Just a different process. This one is, synthetic I think is way shorter, but it doesn't work all the time. You have to do it only if you have a linear divisor. The term you're dividing by has to just be an x. Like this example here, x plus 2. So when we do our coefficients, x plus 2 means a negative 2 out here. And then we fill in our coefficients. We get a 1x to the 4th, followed by a 0x cubed, and then a positive 2x squared. There's no x, so we need another 0, and then minus 5. And it's just those two easy steps, add and multiply. So we add, we get 1, we multiply to get negative 2. Add straight down, multiply to get positive 4. Add straight down, multiply to get negative 12. Add straight down, multiply to get 24, positive 24, and then add those two up, we get 19. Now we build it back up into our polynomial so that 19 gets the divisor. We write it as a fraction over x plus 2. And then this would be our constant. This would be our linear term, so this gets an x. Next we go x squared. That was a positive 6. And then this gets the x cubed, just the next power up, so 1x to the 3rd. Just build your polynomial back up from the right to the left, just like that. All right, that's it. Go ahead and complete your homework, get it submitted to Student View, and I hear from you if you post any questions or comments, and I'll get back to you. Bye.